So I just recorded this whole video, and after I was done, I found out my recording software stopped working. What we'll be making today is a KPI for stock analysis. So KPIs are key performance indicators, and the indicator we'll be looking at is the ADX indicator. Post me just after recording, before the video starts. If you just need the code, or if you just need the data set that I'm using, the stuff will be down in the description. If you're actually here to see how all of this is made, keep watching. I hope really it'll be worth it for you. And ADX is the average directional index for a stock. So if we just go to the programming tab here, I have an OBS. So what is the average directional index? It is that was annoying. It's a technical analysis indicator used by some traders to determine the strength of a trend. If the value is 25 or above, it's a strong trend. If it's lower than 20, then it's a weak trend. And in between, it doesn't mean it is moving. It's just, as they state here, the price could also be making a trend change, or is too volatile for a clear direction to be present. So it's kind of hard to tell. So there's a formula here that kind of explains a bit of the math behind this. And as I just explained, I do have 118 lines of code here where I just did this. So we'll just be doing this in a new tab. And the reason I'm doing all of this is actually because I have a startup called StockTell where I'll be using all of these on my website or on the platform. And I figured one of these things were one of the more interesting ones for you to be coding yourself if you're looking into this kind of analysis and you want to automate the calculation of stuff like indicators like this. So let's make a file we called ADX tutorial v2.py. So basically we will be using pandas for this, and that's pretty much it. And pandas does sometimes, when you're setting values using indexing and stuff, it'll give you an error, or like an error, but like a warning that you're copying some data, which is annoying. I don't know why it comes. Code works, we'll keep it. So we have some steps we need to follow. First off, I want to say Investopedia mostly gets it right. There are some things where they get it wrong. And that's when it comes to the average values or the smoothed values. And also, I think there are some absolute values they're not showing. So they write absolute somewhere, but they don't other places. So we'll be using Wikipedia for the true range, just to help, and also a bit here on school.stockcharts.com. All of the links will be provided in the description as well. So to start with, the first thing we have to do is to calculate the plus DM, the minus DM, and the true range for each period. So what they mean is that we need to calculate these values, so the directional movement and the true range, and we just have the formulas right here. So the positive directional movement is the current high minus previous high, and the negative one is previous low minus current low. So if we just have a calculate val, so we make a method, say method calc val. What that will do is it'll take a data frame, and it'll take a column. Yes, so this will be used, and let's just say pass. So just to start, for I in range, and we'll be doing 1 to the length of the stock data. So stock data, we'll call it. We'll be loading the data in a second. And the reason we'll start from I is because we'll need to look at our current day and the day before that. So, but just for tutorial purposes, we'll just set this to 50. Just so we have some frame of reference and it doesn't spam our whole terminal. So given this, we can then define the data. So stock data equals to, and this data will be provided inside. So you see here my recordings before. We should have a folder here. There we go. We rename, we copy the name. So this is the data set we'll be using. And I'll be linking that in the description as well. So we say pd.read_csv, and then we say data / this.csv, print stock stock data.head just to see if it works, and it pretty much should. And we'll say v2. Okay. So I really wish there was like a clear command in Windows, but I don't know the command. Can I just press, yeah, I'll just press enter till it's clear. I know this is not the way you do it. I'm a Mac user, I'm sorry. It's just, that's the way I know how to do it. Hopefully, yeah, okay, I need to move my window a bit so it doesn't obstruct my code, and also the terminal. So, given this, we have a data set. We've just printed it if we just run it again. Whoops. So we have a data set, but it has a lot of values that we don't need. Now, this data set is from the website Investopedia, where they do, no, actually it's not, it's from this one, I think. It's from one of the guides at least, where they link a data set, and it has calculated these things, so it's kind of a good frame of reference for us. But the only values we need to do this calculation is actually the high, low, and close. I'm going to maintain the date column as well. I'll rename it and maintain it, because if you want to put it into a database or something, you want to have that date column. So given that, we can then say stock data reference is equals this. Actually, no. We'll just print that, and then yeah, we can print the first 50 values, and then we print twice just to empty some space. Okay, so then we say stock. We'll define the columns first that we want to use, and we want to use stock data, and the columns we want to use will then be a list of column headers. So we want to use high, low, and close. Now, when it comes to stock data datasets, the way they name these are kind of different. Sometimes they're in capital letters, sometimes they're in lowercase. It's kind of different. So what I like to do is I'll define a high, low, close to whatever they are. So in this one, they're start capital letter. So I'll just do that. So if I refer to them later on, then it's always the same. So I can just refer to the variable instead of having to change the string every time. So I want to define a list here, columns. And the columns that I would like to maintain are date, high, low, close. And then we say columns, and we say stock data equals stock data columns. Now this should work. Print stock data.head. Date not an index, and that's because we didn't rename the date column. So it's called unnamed.1. So what we'll do is we'll take, actually just do it right here. So we say stock data.rename columns, and we pass it a dictionary. And then we say this gets named to date. There we go. So basically, we take the data frame, we use the rename method, which takes in an argument, which is columns, and the columns takes in a dictionary. The key is the original name, and the value is then the new name. So this should have renamed the columns for us. It did not. Oh, and that is because I need to do, so you could, when you do this, you could say, stock data equals stock data rename, but a method that I like to use is just using the in place parameter. So you say in place true, and then it's renamed in place with you having to, without you having to assign the data frame. So we've just gone from this massive thing down to only these 4 columns, which are of interest to us. The reason why we're printing 50 up here is because we'll need a lot more values. As you can see, it contains 9 values at the start. So we'll need the all 50, and we'll also be changing the print statement for this one as we go. So we'll just remove this print, move it down to the end, and then we can always change the how far ahead we want to look in this parameter here. So first thing we want to do is to calculate value. Now, as stated here, sorry, I'm really itchy today, that's why I'm moving my headset all around and stuff. So we need some current values. So current high and previous values as well. So those are really the only values we need, but we need it for the high, the low, and we will be needing the I think it's previous close for the TR. So yeah, we need the previous close to calculate the true range. So what we'll do is we'll make a method that's general that takes in the data frame of the column, and it'll calculate previous value, and which is the data frame, and then we'll use the lock to index it, and we'll say and then the column we'll be using, which is then column. So that's and that's then instead of I, we'll say I-1 because we need the day before, right? So say we're at index 1, we start at index 1, right? So I'll just show here. So given this, the previous value, we'll then say, okay, the data frame, we index on I-1, we're starting here, so I-1, okay, so it's looking at the previous row, and it says column, and say we define column to be high, it'll say, okay, now we're here. So previous value will be 30.20. Then we can do the same thing for the current value. We say df.lock, I, column. Now we can print, we can say, I'll just make an F string here, and I say current val, previous val. Now this F string is basically just formatting mid string. There are other ways to format. This is how I've always done it. This is a Python 3 syntax, so allows you to give you some syntactic sugar. Okay, so obviously I added the print, but it doesn't really do anything because I didn't decide to do anything with it. So we can call the value, or the method rather. So we say calc_val, not vac. There we go. And we need to pass it the data frame, so stock data. And we need to pass it the column as well. So we want to do this for high, right? So this should print the values, yes. So for the first 50 values, let's just, for the sake of simplicity, just do it for 5 values real quick. So we'll be starting here, and then we're due for high. So we'll be looking at this column, okay? So our current value is 3.28. So we're starting at index 1, or row number 1. And the current value is 30.28, which fits. And the previous value is the one up above that, so 30.20, which is 30.20 here. So that fits. So now we know that for the high value, we get the correct values. Now this, instead of printing it, we want to use these values. So we'll return them. And we'll return current value first, and then previous value. Cool. So now we can basically just calculate DM values for different stuff, but instead of calculating the DMs, the directional movements within this for loop, I'd rather make a method for this. The reason being is that if we look at this, if we have a positive, or if we have a value for DM plus, or the positive DM, we don't have one for the negative one. So you see here we have one for the positive one, we don't have one for negative one. On reverse, if we don't have one for the positive one, we will have one for the negative one, unless they're both negative, in which case we'll end up in a case like this where they're both 0. The value can never be negative, so if it's below 0, it just gets turned into 0. So given that information, we'll pass it a data frame and an index. And that should pretty much do what we want, because we only, yeah. So for the DM, we have positive and negative, and we'll be returning both from this instead of making 2 different methods. You could make 2 different methods, one for positive, one for negative. I'm just using both in one method. So the plus DM is current high minus previous high. So we'll just copy this in so we don't have to Alt-Tab. I'll actually copy the other one as well. Then we don't have to Alt-Tab. So DM plus equals to current high. Let's think, minus previous high. Now you might think, hey, those values aren't calculated, and you're absolutely correct. But we'll calculate them after we've defined this. So DM neg equals to previous low, current low, minus current low. Okay, cool. We've defined this. We can throw out this bit here because it's not actual code, so it won't compile. So we obviously need these values. So what we can do is we can use this calc val, and we can say current high, previous high, calc val, stock data, and then we say high. So because we're doing this for the high value, and then we can do this for low as well. And we just need to change this. So low and low. So this should give us the whatever is this? We'll just try and continue. So this should give us the positive and negative directional movement. So if we just say print dm pos, dm neg and dm pos, there we go. And we obviously need to call the method. So we say we want to calc dm, and we give it a data frame, so stock data. And instead of writing stock data here, we'll write df. There we go. And an index, which is I. Okay. Oh. See, and right now I'm just breaking my own rule. So I already defined the columns here. So instead of me having to remember if it's lower or uppercase, I can just write high and low and use the variables I created. So it's stupid that I'm making variables to make my life easier. I'm not utilizing those variables. So now we've got the positive and negative directional movement variables, but we can't just return the variables per se, because as we see up here, and as I mentioned earlier, if the dm negative is greater than the dm positive, that's the one we return, and the other one gets turned to 0. So we'll just make some conditionals. So we say if dm pos, so if the positive directional movement is greater than the negative directional movement, then that's what we want to return. But this value can't be negative. So we need to check if dm positive is less than 0. We just use 0, we don't need to be 0.00. Then dm positive needs to get just assigned to 0.00. Using double decimals, because that's just what the data is in, so it's a bit easier. And then we'll return, then we'll say dm negative equals to 0.00, and then we'll return dm pos and dm neg. So now we know that the first value we return will always be positive and the second one will always be negative. That's quite important for us to remember. Now reverse, we need to make a statement that says if the dm positive is less than the dm negative, then we want to check if the dm negative first is negative, or, you know, negative. By the way, for the naming conventions, dm negative doesn't mean that it's a negative number, but just that it's in a declining value, or the direction of movement is negative or declining. So we basically say if that is less than 0, then we assign that value to 0, because again, we don't want negative values. And then we set the positive to 0.00. So we're just literally doing the reverse of what we did up here. I'll just make a space for the sake of clean code, and then return it. Again, we need to keep the same order in the way we return things, else Python will just smack us. And I am pretty sure that if we then say dm pos dm neg equals this, that should work. Now, I can already see a small issue. We might get an error here. Okay. Print dm pos dm neg. I think there could be something wrong, but it also could not be. I just want to make sure. So right now we're passing the whole data frame. No, it's fine. It's fine. So yeah, we're passing the whole data frame here, but we're using the calc val. So basically we pass the data frame here just so we can pass it in here, and that's where we basically index what values we want to be working with. So that's fine. So one might think that the first thing you do is then say stock data, and then plus dm equals to this, right? But then you'll say, basically you're saying that the whole column should be equals that value. So what you see is that it's going to be the value that's created at the end, right? So if we say neg, then that would be some value that's not 0.0. Yeah, see? So you're assigning the whole column to be that value. So what we need to do is we need to index, so we're putting in correct column and row. So the way we do that is using this thing again. So just stockdata.log. So we say stockdata, stockdata.log, and then we index by the current row, right? So we say I, comma, and then plus dm. And then we say that is the result of this. And then we can just copy this line and do the exact same for the negative one. Now this should be working properly and give us 2 columns. Yes, so obviously because we need a previous value, it will not exist in the first row, but it exists in all consecutive rows, or subsequent rows rather. And the values are correct. So it's kind of, we will experience some differences in values compared to this data set, because sometimes they cut off values differently than we do. And that sometimes they make like 0.09 to 0.08, or like there are different times where it's kind of weird. So we'll get approximate values and not specific, like straight up equal values to what's in the data set provided. I think they did the data set in Excel, and that might have cut off the values in a weird thing because they're not just rounded numbers. Anyways, so now we've got the directional movement values, and we need to calculate the true range values. And the true range is the greater of the current high minus current low, current high minus previous close, or current low minus previous close. So you see here now we suddenly need some close values. And that's why it's very good that we made the calc val a generic one or a general one, such that we can pass it a column and do it for all kinds of columns. So we just don't need to repeat the code we already did. So we'll make a method again, and we call it calc_tr. Again, do the exact same thing as we've done before. So we just copy this, and then copy it to close as well. Close, close, and close. So that gives us the closing values, the current and the previous closing values. So then we have some ranges and some values. I'll just call them ranges because they're ranges between values. And this is where Investopedia messes up, because it just says it's the greater between these values, but it doesn't mention that some of them has to be absolute values. So we need to make sure that we use absolute in these 2 values here. So basically we just say, we can just copy from here just to make our life easier. Boop, boop, and then we can convert this to code. So current high minus current low, and then absolute, we need to remember that. And then current high, previous close. Oh, absolute current high, sorry, minus previous close. And then absolute value again. And then current low minus previous close. Previous close. Cool. So now we've got all the values, and we can delete this. And if we print this, calc print ranges. So we just want to see that the values we have are correct. calc_tr stock data I. All right. Code doesn't work because I said absolute and not apps. Okay, cool. So now it's created some values for us here, which are then the TR value. So the TR would be the maximum of the values in this list. So that would be 96 here, it would be 48 here, it would be 136 here. So, and I think this is where our values will start to differentiate itself from the pre-calculated values in the data set. So we say the TR equals max ranges. So we just want the max value in the ranges list. And you see we have unused variables here, but that's just because of what we're returning. Python will take care of trashing that data because it's not getting used anyways. So as soon as the method's not existing anymore, the values won't either. So cool. And then we'll return tr. We could just say return max ranges, but I just wanted to make this explicit what we're doing. So we can then say stock data.log I, comma, tr equals to tr. And then we'll define tr up here. Tr equals calc tr stock data I. All right. This should, for our 5 rows, create a tr value. So we have 0.96, 0.49, and 136. So let's see. Tr 0.96, 0.48, we have 49 and 136. So yes, it differentiated as I expected, but it's correct. Cool. And we got the true range. Now we need to make the smoothed values of this. The TR formula is below. The formula is apparently the same for all of them, so you just change between TR and directional movement, so true range and directional movement. So the first value is different from the subsequent ones. Instead of using this bit here, I just want to use a bit more explicit explanation as to what it is, because this is what they're using. They're using what's called Willis smoothing techniques. So the first is just the sum of the first 14 periods of TR1. And then I don't know why they've explicitly written this out, because the second and the subsequent is the exact same thing. So the first is just the sum, and then the subsequent is the prior minus some other things. So let's do that. So we make a method again. We say def calc first 14. So, and the reason we say for and not tr is because we use it for directional movement values as well. So pretty sure we can do this. So we will then say result, because we need to sum over this, right? So we say result equals 0 using this formula right here. Boop, here. This is the formula we're using. Okay. So we're basically summing over that. So we just sum the first 14 periods. So we say for I in range, and since we're only using this once, we'll just say for I in range, index minus 13 up till index plus 1. So for 14 values, just for explicitness, is that the word? I'll print I just so you can see that we get 14 values. So we will say calc first 14 stock data I, and we do this for tr. It doesn't really matter right now. Stock is not defined. Ugh. Okay, cool. So, oh yeah. Oh yeah. Okay, so I can also explain why that happens. But you see, we have 2 values here that's negative, and then we have 12 values that's 2 values here that's positive, sorry, and 12 values that's negative. So the reason why it's doing this is because we're trying to index negatively, and we obviously need to only look back to where we have values. So we need to make a statement now. And what we'll do is we'll count if there are enough values that we need. One way to do that is to say if stock data dot, and then you can select a value or a column, and you can do that by putting dot, and then we say tr. And then if you do count, it'll count all the values in that column, not counting nan values. So because we do have a nan value on the first here, it'll basically count how many actual values are in the tr row. So this row right here, right? A column. But for this, as we need 14 values, we also need to increase the range. So we'll increase it to 20 for now. And we do that. And then we say if the count is equals to 14, because we need 14 values, right? then we need to do this. So now we should get, yes, it counts to 14, so it's doing what we want. And it's only doing that when there's 14 values. So now we know that the condition actually works. So for this, now what we want to do is we want to create a value, or we want to sum this value, sorry. So we say result plus equals, and then we do it over the data set, or the first 14 values. So we go, let me just think real quick. df.log I, say tr. I don't know why I'm starting with tr. Let's just do that. And then we'll print result. This should give us the sum over the tr values for the first 20 rows. Okay. I don't know. Oh, because we're printing ahead, right? Yeah. So we need to, yeah. So we also need to increase this. So just for the sake of simplicity, we'll see display data equals 20. And then we can set the range to be a display. Let's call it display range. So we only have, we just change it to one place instead of two. So there we go. So the very first time a TR value is generated, which would be on the 3rd of March, 09. This is when we should have a smoothed value for the TR. So if we go to the 13th of March, sorry, 13th of March, there we go. So right here, is that correct? That should be correct. Let's see. Did I just say something really stupid? I think I meant this one. 14th even. There we go. My math was wrong. I'm very sorry. So 4th of March, sorry. That's when we have our first TR14 value, which is 13.33, and ours is 13.36. So given that our values differentiate themselves a bit, this is correct. I'm just keeping an eye on the recording. It still works. Thank God. So we know this works. So we say if it's 14, then stock data dot lock I tr14 equals this. So basically we only assign it to that one return result, sorry. So we only assign it to that one row and not any rows after that point. So we need to make a condition because this all the subsequent values are calculated with a different formula. So we need to make a statement where we say elif stock data.tr.count is greater than or equals to 14. Then we do some other stuff. I'll just make a space here. And we can just copy this because it's basically the same and then call this subsequent. Okay, and we make a method now. Again, so we're making a lot of methods, but it just makes it easy for us to divide this into code that we can use. You could actually put this in a separate script and then call them if you need them, but yeah, we're just doing it in one document. So basically we do df and column. I don't think we need the index. I'll just put in the index. We can always delete it. And then column. And we'll only do this for TR right now, and then we'll fix the directional movement ones afterwards. So we don't need result because we're not summing anymore. So basically we're saying the prior TR14 value. So let's say call it smooth just for the, let's not assign it right now. We'll assign it afterwards. So the prior TR14. So we say df.lock index -1 because it's the prior one, and then it's the TR14. So that would be the column instead, not TR14 explicitly. We also need to fix that up here. I can already tell. There we go. Minus, and then there's a parentheses, the exact same value divided by 14. And 14 is because that's the smoothing window that we've selected, plus our current value. So we just say, there we go. Now, this is the exact same for the directional movement values, but just for the sake of showing you how it'll look, what is the error here? Assigning result of a function call with a function. Oh, it's because it's not returning anything. Yeah. So we can basically just return this one-liner. And this should create the TR14 values for all the subsequent ones. Now, I've obviously made a mistake here, so let's find out what that is. Because it's not supposed to be ones here. Pretty sure. Yeah, it's supposed to be around 13 still. So let's see. Oh. So at the end here, I put TR14 instead of TR1. So what I'll actually do, as I'm making this a generic one, right? I don't remember, how did I do it last? Oh. You see, I even answered my own question earlier. So basically, we'll just say the column plus, and then 14. Boop, boop. I think that should work. There we go. So yeah, I just forgot to explicitly say they should be looking for TR14 because I'm passing TR, so it's looking in this column right here instead of this one right here. So yeah, now it's giving the correct results. So 13, 13, 13, 13. That should fit with what's here. 13, 13, 13, 13, 14. Yes, correct. So we're only 0.0x decimals off. X because it's a variable, due to the way they treated some of their data. So now we've done it for TR, right? We want to do it for the DMs as well, or the directional movements. So we'll say plus DM and minus DM. And then we say plus DM here and minus DM here. That should work. So let's just check, and it'll only create the first value as we see there. And we can do the exact same thing down here. So we just change the function call to the correct one. And now we should have some values. Perfect. Now, I really want to, just for the sake of keeping it clean, want to round it to 2 decimals because that's the way the rest of the data is structured. So we'll just change the return thing to, or we can just round it here, actually. Round this, 2. 2, 2. Add a space for simplicity, or cleanness rather. And we change it around. There we go. That should round the values. There we go. So now we have double decimals all the way through. Cool. What is the next step then? And we're getting close to being done with calculating the ADX. So we got the smoothed values. So we need to calculate the DI values. Yes. So the DI values, directional indicator, pretty sure that's the definition of them. Let's just see to be 100%. Directional indicator. Yes. Okay. So the positive directional indicator is the DM14 divided by the smooth TR. Okay. So we should also have the equation here. Yeah. So, and that's where this gets annoying. It's they call it a smooth plus DM, but an ATR for average true range, and that calling this an average positive directional movement index. So it's the naming convention they use here are really, really bad in my opinion, but it is what it is. So we know for this, and it should be rather simple actually. We can just put in the same condition, stock data.log and this is where if I knew VI or Vim, I would be way quicker at doing this. So we say plus DI equals, and we'll just make a round. Cool. So we need to first make a parentheses because we see that it has to be multiplied by 100 and this has to be multiplied by 100. So we just took care of that first. So some value, which is the plus dm. So this right here. Has to be divided by this value right here. Boop. Now this should work for getting the plus di. And it does. But it doesn't in the row after. And it's not supposed to do that. Oh, okay. Yeah, so you see, we could like copy paste this code and write it twice, which is just really bad practice. So what we'll do is we say if tr14, because it's a string, in stock data.column. So we'll just check if it exists in the columns, and if it does, we'll do this. Because then we know the value has been created. And that should make sure that, yeah, that we see. It creates it. The DI is 7. Is it correct? Okay, we're quite, it's rounded. It's because of course it's rounded when I don't give a decimal around. There we go, 6.6, 6.2, 5.7. Let's see, 6.7, 6.2. Yes, so we're still getting roughly the same numbers, so that works. And we can do the same for minus di, which is just minus dm and not plus dm. All right, so we've got all the values we need to make the directional index, which is down here. So the dx is positive di minus negative di. And we actually have the equation here, and then we need the absolute value. So, and that has to be multiplied by 100. So we'll just do that. And then we say stock data.log I, dx equals 2. Again, we just round to 2 decimals because we like that. Then we have this, which is multiplied by 100. So now we've just fulfilled all the outside criteria. And then we need to take some absolute value and divide it by some other absolute value. So now we've basically given the framework for the calculation we have to do. So we have to take the positive minus the negative and the upper part. So we say this divided by the negative. Not divided, minus, right? Yeah, minus. Wow. So we'll just fix that. So minus here. Let's just make some space here to make it clear what the hell is going on. That had to be, oh, this is correct. Okay. Pretty sure. Yeah, it is. Cool. So it's plus for the first one and minus for the second part, right? So we'll take this, put it in there. Cool. And that should give us the dx values that we need. Cool. And we did it wrong. Nice. So I have feelings because we didn't change this to plus. So we basically just divided by itself and it gave 1 and then I multiplied by 100. So now we have 65, 78, 72. Let's see. 65, 78, 72. Surprise. It's correct. Okay, cool. So I'll just reiterate what we just did. We created the plus, a positive directional index and indicator and the negative directional indicator using the formulas right here. So this one and this one. And we did that for each data point. So again, we're iterating over the rows and then deciding what column we want to be using by using the lock thing on our data frame. And then we've basically created our DX value where we have to take the absolute value of the positive minus the negative directional indicator, and divide that by the absolute value of the positive plus the negative directional indicator. Then we take that and multiply 100, and that gives us the DX values. So now ADX is kind of the smooth version of our directional movements and our tree range in the way that it changes whether or not it's the first value. So what we'll do is we'll make two methods. We say calc first ADX, and it'll have some arguments, and we'll just write pass to start with. And then we'll make another method, which is def calc ADX, which is take some other arguments, and that's also just pass. So for the first one, we'll take a look. And I'm pretty sure this is actually stated here. Yes, so the first ADX is just the 14 period average of DX. So it's just the average of the prior ones, or the, like for the first one, it's the average of all the DX values, and then after that, it's this formula right here. So given that information, we'll just paste it in. Just so we have a frame of reference. So we do actually the same thing we did up here, like exactly the same thing. We can literally just copy the code because we need to do some kind of sum, but instead of sum, we'll divide. But it should be roughly the same thing we're doing. So we take, instead of writing column, we'll do ADX, DX, because it's the DX values. We just do df index here. So again, we need the first 14 values. So we're going 13 days back, including today. So that's 14 values. We're adding that to the result, and then we're just averaging that. So we have 14 values and averaging that. So this should give us the first ADX. And then we can say, if we have, because we need 13 DX values. So we can do the same thing as we did here, right? We need 14, sorry, not 13. So if the DX count is equals to 14, print A. Okay, we just make sure that we get, when we get one, it'll print that. Data frame has no DX value. So we need to check for that as well, because just as we did here, we can basically do this. So the reason why it's complaining is the very, very first time it does all this, it'll go through, it'll pass through these conditionals and do what it has to do. But then it'll get down here to this part of the code, and it says, does TR14 exist? No. Sure. Okay, we'll just pass on. Again, we're only the first row, and then it'll, if you say if stockdata.dx.count equals 14, it'll go look for the DX column, but that doesn't exist yet because that gets created in this clause, right? On this conditional. So we'll just indent this and make sure that the DX column does exist, which is created in the previous condition. And then we can try again. Cool. So we haven't defined anything, but it should print, hey, hello. No, it didn't. Print hey here. That should give us a lot of hays. Okay, yeah. Oh, yeah, okay, so I know why it doesn't work. So now we need to, once again, expand upon the display range we're working with. So we'll change that to 50. And we should get something now. Yeah, there we go. So, and that's because it needs 14. So the DX needs 14 of these values, and then the ADX needs 14 of the DX values. So pretty sure that it'll actually right here where I marked, or it's in the 27th row, 27th or the 28th row. That's where it'll create the ADX value. So what we'll say is stock data dot lock I ADX equals to calc first ADX stock data I. Cool. So again, it's only the first value. It's on the column number, row number 27. It'll only calculate the first value, which is 33.66, 33.58, a bit off the mark, but it's correct. Again, our values is a bit different because of the way they've calculated their base values. So now we can do the exact same thing as we did earlier, where we say if it's greater. So we just do that. So we say if, and then we say dx instead of tr. So if that's greater than 14, then we'll use this function. So we'll basically just copy whatever we just wrote. Oh, I need to put that in there. So again, just to explain, I'm copying a lot of code here to make it a bit quicker so you don't have to wait too much. So basically what we're saying is that if there is more than 14 dx values, then we have to use the separate second formula, which is calc ADX. And that's what we need to then make now. So the subsequent ones is then just the prior ADX value times 13 plus the current value, and then all of this divided by 14, right? So we'll just copy this, put it in, and then we'll convert it to code. So the prior value, which would then be, again, we give it a df, a data frame and an index. There we go. So that would be data frame.log, and then index dot index minus one, sorry. And then we want the ADX column. So we say ADX, and we'll take this and multiply it by 13. Now this right here, we have to multiply. Oh, no, not multiply. We have to add this to the current dx value, not ADX value, but dx value. So we say df.log, and we say index, because it's the current value, dx. Now, again, this we'll put it in a parentheses. There we go. And all of this has to get divided by 14. So we get an average dx value. Delete all of this. And then we can say, return this. Actually, let's just round it real quick. Round. Pretty sure. Yep, I need another parentheses round. Comma 2. There we go. So, and the reason I round is, again, is just keep it to the double decimals. That's already the data set. We have, so there we go. Cool. So now we've created the ADX column, which gets created at the 27th row, as I predicted. So let's take a look at the values. 33, 32, 30, 28. 33, 22, and 29, 28. So it's pretty much the same values. Again, we're talking 0.0x value difference, but yeah. So that basically works for this display range. We could just remove the display range. We can say 20 here. We want, no, it's actually, yeah, so we print the first 50, but we also want to print the last stock data. We want to just make sure that it works to the end of the data set. And I'll show you why in a second. So we're just printing the first 50, and we want to print the last 5 as well. We don't need any reference anymore, so we'll just delete that. I'm not sure if it still prints hey, it does not. Cool. So we run the code. Display range is not defined. Well, thank you. Okay, so it even caught the error I wanted to show you. So let's say I do 50 here, right? Which it was before. You'll notice that at the tail it has NaN values because we obviously need to go through the whole data set. So we'll say to the length of stock data. There we go. And that should, there we go, should fill out all of the data set. Okay, so now we've actually come to a point where, and this is something that we didn't take care of in one of the methods here. Yes, in this one. So we have two scenarios, and that is if our directional movement, positive directional movement is greater than our negative, or if it's the reverse, so if the negative is greater than the positive, then it returns values. But we're not taking care of the case in which they're the same. So if dm pos is equals to dm neg, and in that case, my stomach is really rumbling because I haven't eaten today. In that case, and that's just else, because it's the only last case, and that's why we don't need to use an elif, we can just use an else. There is no real example of what to do in that case. The code that I used for inspiration for this was, it's a really shit code, by the way. Didn't take care of it either. it just converted both the values to 0, which I don't think is the way to go about it. So I'll return the dm positive value. So I'll say if dm pos, I'll basically just say this, right? This is literally just what I'll do. I could also say, or if dm pos equals dm neg, but I'll just do these 3 clauses and then that should take care of everything. So this should work, and it should work for the whole data set. That's why it takes some time. And there we go. Calculate it for the whole data set. We have ADX values, DX values, plus and minus DI, 14 DMs, and TR 14. So we've literally just created the ADX value for this data set. And then we can always change what we want as the data we're using. So say we're using this data set, right? IBM. So you see open, high, low. So we'll just change that. And in this data set as well, we see that it's called timestamp. So we'll just change the renaming to timestamp. And then we'll change the capital letters on this, and it should work perfectly fine for the IBM data set as well. None of these are in columns. Oh, obviously we need to change the name of the file we're using as well. Daily adjusted IBM. There we go. Date, not an index. I literally just renamed you. It's not capital T. That's why. There we go. So we just tried a completely different data set, which is some recent prices from IBM. So that goes back, what, 1 month-ish? Okay, so it's in the reverse order. So we just need to calculate, we can just say reverse pandas data frame. Okay, so this apparently reverse it, so we'll just do that real quick and it should work. There we go. So the start values, yes, cool. I don't really care about the index values. We can reset index as well if we want to do that. He actually did say it in here. Maybe we can actually do this. I think we just use all the snippet he gave. That didn't work. Why didn't it work? Okay, yeah, so what we literally just did before. There we go. Thank you. So the last 100 days, I guess, is from this data set, and it starts from 2020 6/26 to 2021 11/16. So that is up until yesterday, and that's the ADX values up until that point. So it's quite useful, and you can use it on any stock really. You just need to keep in mind the naming and the names and all the columns, and change it to whatever data set you have. I'll be providing this code on GitHub. I might clean it up a bit more, and I'll be pushing it to GitHub and provide a public link for you guys to use, along with the original data set that I made the code for. But yeah, I know this was a quite long video. I haven't really done these before. I think I might be doing this for some of the code that I'll be making for StockTell. Also a link to in the description to their website. If you want to become a beta tester on the website, just go sign up. It might also be released in the beta by the time you're watching this, but hopefully this was an insightful video on the ADX. A bit long, but it takes a lot of time to create code. Keep in mind, I had to do this 3 times, so I've literally just spent 3-4 hours making this one video. I'm speaking quick because I'm really hungry. Thank you so much for watching, and hopefully I'll see you next time.